In this review, we're going to look at biotechnology. So remember, gene therapy is where we go in and we actually change the DNA to fix genetic diseases like cystic fibrosis. Stem cells are cells that have not yet differentiated, so they can become different cell types. And they come in the form of embryonic stem cells, which are used when you're a developing fetus, and so they can develop into any type of cell, and that's how you get all the different cell types in your body. Once you're past that stage, you only have adult stem cells that can only become one type of cell. So for example, they can become blood cells. We would like to be able to use embryonic stem cells to help do things like regrow organs and things, but remember there's a lot of ethical concerns surrounding that. Now let's look at transgenic organisms, which remember are organisms where we have added DNA. So we have taken the gene out of one organism and put it into another. And we do this for a number of reasons, including making medicines like insulin and agricultural purposes like creating GMOs. Now, when we're trying to create a transgenic bacteria, what we're going to do is we're going to start with the gene that we want. So for example, let's say we're trying to make a bacteria to make insulin. So we're going to take the insulin gene and we're going to use a restriction enzyme, which are like biological scissors, and we're going to cut that gene out. Then we're going to take a bacterial plasmid, which remember is a small piece of bacterial DNA. We're going to use that same restriction enzyme, cut the plasmid, and then insert the gene. And this works because we're putting DNA into DNA. Now next, we're going to take our bacteria and we've got to get this plasmid into the bacteria. When we do that, we have created what's called a transformed bacteria because we have transformed it into a new organism that's never really existed. It has a human gene in it. And then this transformed bacteria, because it's got this gene, is going to be able to produce the protein that we want. So for example, insulin that we can then package up and send out to people that have type 1 diabetes. Finally, let's look at DNA fingerprints. So remember, in order to make these, we're going to use gel electrophoresis. And in this process, we're going to take DNA. Again, we're going to use restriction enzymes. And we're going to cut the DNA up to make fragments of various size. Now we're going to put these fragments into a gel. And this gel, remember, is kind of like a briar patch. And then we're going to let this DNA move through the gel, these different fragments. And they're going to create a DNA fingerprint. It's called a fingerprint because it's unique to every person. Now these are what we call bands. And each band represents a different DNA fragment, a different sized fragment. So remember, because this is like a briar patch, the largest fragments are going to move the most slowly, whereas the smallest fragments are going to move the most quickly, so they'll be found at the bottom. Now, we can use this for a number of different things, including paternity. So here's an example of using it for paternity, trying to figure out who is the child of this guy Megabucks. So for me, the best way to do this is the child's bands have to be found in either the mom or the dad, and they all have to be accounted for. So you know who the mom is, so go ahead and you just mark out the ones that are found in the mom. So notice I have simply just deleted out the bands in the children that are also in the mom. Now, for clarity purposes, I'm just going to get rid of the moms as well. So now what we're saying is, if these children are Megabuckses, then the remaining bands have to be found in his DNA fingerprint. So when we look at X's kid, right off the bat, no, not his child. Y's child, on the other hand, all of those bands are accounted for. That's his kid. And then again, Z, Doesn't have that band, not his kid. And so while we can use DNA fingerprints for a number of different reasons, all you basically got to do is just match up the bands.